All right, let's look at the chain rule again, revisit the chain rule in preparation to talk about the implicit differentiation next. All right, so remember the chain rule, right? Maybe I should write that down. Chain rule goes something like this. If you have a composition f of g of x, then if you want to take the derivative of this composition, what you do is take the derivative of the outside, but the inside function stays the same, then you would have to multiply by the derivative of the inside function. All right, so that was the chain rule. All right, let's see if we can understand the difference between the following two things, two derivatives. All right, let's say y is a function of x, so I'm going to call it g of x. So y equals g of x. All right, so what would be the difference between derivative of y cubed with respect to y and the derivative of exactly the same function y cubed with respect to x? So you can see that here the difference is with respect to y or with respect to x. All right, so here's the difference. All right, so if you take the derivative of y cubed with respect to y, all right, so with respect to just means that we're going to look at this function as a function of y, all right? So y cubed derivative is just simply applying the power rule. So this is going to be simply put the 3 in front, y, then subtract 1 from the power. So 3y squared. All right, so this is the derivative if derivative done with respect to y. All right, what if you take the derivative with respect to x instead of y? All right, so this might be easier if you rewrite it a little bit. I'm going to rewrite this guy as, all right, so I'm going to put the g of x back in. So we're taking a derivative with respect to x, so I'll take care of that. All right, but inside you're going to have y is g of x, so I'm going to put g of x. And you have to cube that because since it's a y cubed, right? Then we're taking the derivative of that, right? So we can simply apply the chain rule, or you can call it probably a general power rule in this case. But the derivative of this, we know how to do it. All right, outside function is a cubic function, so you put 3 outside. And then inside function stays the same, so g of x stays the same. And subtract 1 from the power, so it's going to be squared. But because of the chain rule, you have to multiply by the derivative inside. So you have a g prime of x. All right? So this is the correct derivative. We know how to do it. But if you go back to y, this is the expression we get. Right? So you have a 3, right? Remember, g of x is simply y, so you have a y, then squared. Then you have to multiply by derivative of g, which is the derivative of y. So I'm going to call it, you can write it y prime, or we can write it as a dy over dx, same thing, right? All right, do you see the difference between these two guys? All right, so here is the derivative with respect to y. But the same function, but if you take the derivative with respect to x, then you see that you have this extra factor popping up, right? So whenever you take the derivative of an expression with respect to the variable that's written in, then this is just going to be a regular derivative. So it's exactly the same way we have been taking a derivative. You go ahead and take the derivative, right? But when you have expression, this which is written in y, but we're taking a derivative with respect to a different variable, in this case x, then what you need to do is you just take the derivative in a regular way, which will get you 3y squared. But because of the chain rule, you have to multiply by derivative of the original variable the function is written in with respect to the derivative you're doing. So you have, in this case, dx. So you should put dx there. Right? Do you see the difference? Right? So let's look at the following a simple example so that we can apply these differences. Right? So let's say we want to take the derivative of x squared plus y squared plus x times y with respect to x. Right? What kind of derivatives can we get? Right? So this is equal to, all right, here, if you take the derivative of x squared and with respect to x, so you know the variable matches, all right? So therefore, this is a regular derivative, so you know that the derivative of x squared would be 2x, no problem. All right. Now, second term is y squared. Now we're talking about different variables. So what you do is you take the derivative of y squared with respect to y first, which is going to be 2y, but you would have to multiply by derivative of y because of that chain rule. Right? All right, third term is a little bit tricky because this is a multiplication, so we're going to have to incorporate the product rule as well. So you have, this is the first guy, and here is the second guy. So we take the derivative of the first guy, derivative of x is 1, right? Multiply by the second, which is y, so don't do anything to that, right? And the first guy is x. Then you have to take the derivative of y. It's not going to be 1, it's going to be dy over dx. Right? And there's not much you can do, but we can clean it up a little bit, I guess. So you're going to have, right? There's a 2x. Definitely we took care of that. All right. Then next thing we can do is we can actually, I'm going to just take care of this guy first. So 1 times y, so it's going to be just y. All right, and here we have two terms, but these guys have the common factor. So you have dy and dy over dx, so that's in common. So I'm going to pull those two out. So you're going to have a dy over dx, right? Then we collect the leftover factor. So you have 2y from the first guy, and then you have a plus x from the second guy, right? So that takes care of everyone involved, right? So that is the derivative that we're looking for, right? That's it. I hope that this was clear.